Hi guys, it's me Sitanga back again with Learn with Sitanga, and today in this video we're going to be looking at an integration question from the Edexcel IAL P2 Mathematics, and this is from the 2022 October P2 paper, and this is question number 6. Alright, curve C1 has the equation y equals fx, and the table of x and y values we have. The y values are rounded to 4 decimal places. We have to use trapezium rule with all the y values to find an approximation for the integration of fx with the limits 2 to 0. Alright, so just to give you all an idea of what trapezium rule is, it's simply estimating the area under a curve. Alright, so let's say I have this y-axis and this is my x-axis, and if I have a curve like this, what it simply means is we are dividing this into small trapeziums. Now these are trapezium, not rectangles, so we have trapeziums. Alright, we are dividing this area under the curve into small strips of trapeziums. Small trapezium, we call them trapezoidals, so we split it into small trapezium strips. Alright, and the number we can split this into a lot of trapeziums, or we can split it into less number of trapeziums. Alright, and the width of each trapezium here, now if I split it into 3 here, the width is this thing, this width. Alright, this width is called h, and if I have more trapeziums, like if I split this further into more trapeziums, if I split this into more and more trapeziums, I'd be having a small h, because the width of each strip would be smaller, because I would be having more strips, right? So h means simply the width, or if I redraw another one here, if I have a curve here with, let's say I have 2 trapeziums, h is the width of one strip. Alright, one strip of trapezium. So we have many strips of trapeziums, and width of one is h. So to find h is simply the x value difference. See in here, from 0 to 0.5 I have 0.5 difference. From 0.5 to 1, again 0.5, again 0.5, which means my h is 0.5. Alright, so my trapezium rule, in order to find this, we have our trapezium rule. Our trapezium rule says the integration of fx, okay, is equal to h over 2 multiplied by I have y naught, which is my initial y value, plus 2 times y1 plus y2, and it goes on until the one before the last. So everything is multiplied by 2 from y1, which is the second y term. Y naught is the initial one. So from y1 up to the second last one, it is multiplied by 2. Each one is multiplied by 2. And then you finally add yn, which is the last one. So in this case, in my example, y naught would simply be 3. And yn would be this, y1, y2, y3. Alright, so what we would be doing is, I would have my h is what, 0.5, to y naught is 3, y naught is 3, so I'd have 3 plus 2 times all of the other ones except the last one. We have 2.6833, we have 2.6833, let me write that down, 2.4 and 2.1466. So I have 2.6833, 2.6833 plus 2.4, and then I have 2.1466, 2.1466, and finally last one, yn is, right, last one, and the first one is alone. First one 3 and last one is around. All of these 3 are multiplied by 2, right? And when you put this in the cal, you get an answer for this. So now we get an answer for 0 to 2 of fx. So guys, by using trapezium rule, what we actually get is an approximation for the area under a curve, and we usually use this method when our normal integration method would be difficult, right? 2 times this plus 2.4. And they can ask in exam questions, how would we improve the accuracy of this? So in order to improve the accuracy, what we would be doing is, we would be using more number of strips. That means if I use more number of strips, breaking the area into more number of strips, my answer would be more accurate, and the h in that case would be low. So when I put this thing guys in the calculator, what I got was an answer of 4.85 when I round it up. 4.85. Part B guys. Now this is an interesting part. I have curve C, then there's curve 2. Curve 2 has the equation 2 minus 1 over x square. That is curve 2, right? And the region R forms part of the design for a logo. So this is the logo. This rectangular part is a logo, and R is part of the logo. So they are saying here, design consists of the shaded region R inside a rectangle. The region R forms part of the design for a logo. The design consists of the shaded region R inside a rectangle of width 2 and height 3. So this is a rectangle with width 2 and height 3. In that, this is a part. So this is a logo. This is only a part of the logo. So region R, we know it's bounded by what? Curve C1, C2, x equals 2 line, which is this, and the y-axis, right? This is bounded by this y-axis, curve 1, curve 2, and x2. This is very simple to approach, guys. Using calculus and the answer to part A, calculate estimate for the percentage of the logo which is shaded. So now in this logo, what is the shaded part? It would be R. So they are asking percentage of the logo that is shaded. That would be area of R divided by total area of rectangle. What is that? Simply 2 times 3, right? They are asking percentage of this out of the entire rectangle. Total area, so area of R divided by total area of rectangle multiplied by 100. This would be your answer. Alright guys, so how would we go about solving this? It's pretty straightforward guys. Now when you look at this, alright, region R can be found if I get the area under curve C1. Now area under curve C1 would be what? It is this from here, all of this stuff, right? All of this stuff under that line. If I take away from that this region, and area under curve C2, area under curve C2 is this stuff, right? This stuff are area under C2. All of these are included in area under C2. So from that full answer here, from this full area, if I minus this yellow section, I would get my area R, right? So what I need to do is area under curve C1 minus area under curve C2. Now the area under curve C1 we already found. So we'll first write an expression for part B. So we know part B, area of R equals area under C1 minus area under C2. Alright, so area under C1 is actually our answer to part A guys, because from the trapezium rule what we find is the area under a curve. So now C1 we found C1 is fx, y equals fx. So by using trapezium rule here, we found area under C1, which was 4.850. So I'm using that answer here. Area under C1 would be 4.850 minus, now I have to find area under C2. How would I find area under C2? Area under C2 would be the integration of this equation, C2 equation they have given. If I integrate this with the limits x equals, we have 2 and 0. So if I get the area under this, that is a yellow area. If I integrate this between 2 and 0, I have 2 minus 1 over 4x squared. So this would be minus the integral of 2 minus 1 over 4x squared, and I have to integrate between 2 and 0, guys. Okay, so here I have 4.850 minus, now I have to first integrate this. Alright, when integrating that, guys, I have 2 becomes 2x and minus 1 over 4x squared. I have minus 1 x to the power, we add 1 to the power and divide by the new power in integrating. So x squared becomes 2 plus 1 x cube. When I divide by the new power, I have 4 and times 3. 3 is also divided, guys. So here it becomes this with the limits 2 and 0. I have to substitute the limit here. So I have 4.850. I'm not engaging that in here, I'm just leaving it aside. When I substitute 2, I get 2 times 2 minus 1 is just there, so 2 cube over 4 times 3 minus, when I substitute 0, it simply becomes 0, guys. This part you actually don't need to show this because it's simply 0. This part is 0. So it's fine if I get this answer only. So here it becomes 4.850 minus, when I substitute this, I get 2 times 2 minus 2 cube over 4 times 3. This gives me an answer of 10 over 3. This is 10 over 3 minus 0. So this final answer is 4.850 minus 10 over 3. This is 91 over 60. 91 over 60, guys. Alright, 91 over 60. This is an area, so it is unit squared. So you don't need to show that part for now because we don't have any units. This is area of R. And the way we found, guys, just to remind you all, area under C1 minus area under C2. Area under C1 is this red part, that minus area under C2, which is the yellow part, it gives me R. Okay, in the beginning we told area of R divided by total area times 100 gives me the percentage. Now what is my area of R? It is 91 over 60. So the decimal answer is 1.52. That is 1.52. I got 91 over 60, which was 1.52. So I'd be using that here. Area of R is 1.52. Total area of the rectangle is 2 times 3. And this is multiplied by 100. So 1.52 over 6 times 100. This gives me an answer of 25.28. Hope you understood, guys. Thank you for watching.